The next thing we're talking about in 9.6 is the surface area of cylinders and spheres. So our cylinder looks like this picture above. It's like a can. And our equation for total area of this cylinder is 2 pi r squared plus 2 pi rh. This right here tells me the area of the circles on top. So this is the area of my circles. Because remember, the area of a circle is pi r squared. Since I have two circles, I have 2 pi r squared. Now this here tells me the area around the cylinder. So if we know that those two pieces, we have the area of the circles and then the area around the cylinder, our lateral area is going to be that total area minus the area of our two circles, which is 2 pi r squared. And that's going to leave us with just this area around the cylinder, just the 2 pi rh. Okay, so let's look at an example. If we want to find the total area and lateral surface area of this cylinder, and we are given that, actually let's go back up to this cylinder first because I forgot to label. We want to make sure we know that this line right here, this is our r, our radius, and this line from the center of one circle to the center of the other, that's the height of our cylinder. Okay, and that's also measured on the outside here. This is the height of our cylinder. So now if we know that below that the height of our cylinder right here is 17 and the radius is 7 inches, we want to find the total area and lateral surface area of the cylinder. So right away we can write our equation down. We have 2 pi r squared plus 2 pi rh. And when we plug in those values, we know our 7 is r and our 17 is h. So we have 2 pi 7 squared plus 2 pi times 7 times 17. Plug all that in my calculator. This first part, I get 307.72 plus 747.32. Add those up together, we get 1,055.04 inches squared. That is my total area. Now for my lateral area, I'm going to take that total area that I just calculated and subtract the area of my two circles, which is 2 pi r squared. So it leaves me with just what's being wrapped around that cylinder. Plug those numbers in, I get 1055.04 minus 2 pi 7 squared. And when I plug that in, it's going to leave me with 747.32 inches squared. Next, we're talking about spheres, and our spheres are a little different than the last three objects we've been looking at because our spheres do not have a lateral surface area. They only have a total surface area because our spheres do not have a base. Spheres are circular all the way around. There's only one area formula that we can calculate, and that is our total area around that sphere. Our equation for total area is 4 times pi times r squared. And our r right here, our radius, is from the center of that sphere to the outside. So if we look at our example, it says find the total area of a sphere with a radius of 7 inches. Well, our total area, our equation is 4 pi r squared. And when we plug in an r of 7, we get 615.44 inches squared. That is our total area of a sphere. Now if we have number 2, they're telling us that the surface area of a basketball is 452.16 inches squared. Find its diameter. Well, we know a basketball is a sphere. So we can use our area formula for a sphere, which we just said our total area is 4 pi r squared. Okay, so if we know the total area, we can plug that in. 452.16 equal to 4 pi r squared. R is our only variable now, so we can solve for r. If we divide both sides by 4 pi, that leaves us with about 36 on one side and r squared on the other. To get rid of that squared, remember the inverse of square is square root. So if I take the square root of both sides, I'm left with r is equal to 6. Now that I know what r is, I know that my diameter is 2 of r, and 2 times 6 gives me 12. So I know my diameter of that basketball is going to be 12 inches.